My name is Dr. Uli Hansen. I'd like to talk about microstructured glass and silicon components for optoelectronic packaging, the key focus of what LITHOGLAS does. So, shortly on our company, we were founded in 2006. We have 2 sites in Germany. Our headquarters and production is in Dresden, and we maintain an R&D corporation in Berlin, and both sites are ISO 9001 certified. Now, what we do and what this talk is also about is that we use wafer-level packaging technologies, but also use those for making miniaturized SMD and COB type of packages with a strong focus on opto-electronics. And we make these parts ourselves, and we have a specialized foundry service for making such parts. Now, in the focus opto-electronics, you can see several the examples here, so that's mainly sensors and emitters. And the key is always with the semiconductor technologies and the MEMS technologies that we use, we have a focus on miniaturizing parts, making hermetic, reliable packages, and wherever applicable, enhance the optical performance. And using semiconductor technologies, of course, we have very good precision, and with that also working on wafer and batch level, a very high scalability of our solutions. And we use that as shown in the bottom, and I will get into these examples a little bit more, and I'll start off right away with a UV LED. So that's deep UV. And on the left, you see how these are packaged currently, mostly. So that is either the very classical TO package, glass metal can, or for an SMD type, it's a ceramic cup with a lid that's glued or soldered on top. And in the case of UV LEDs, this is not an efficient way of packaging, because these LEDs emit a lot of light to the side that in these packages is then just lost in the side walls. Also, you have a high assembly effort with the TO cans, or also to assemble into the ceramic cup here. And making arrays of packages is troublesome or more bulky. Now, with our solution, we can make on wafer level windows that are fit over the part. And in both cases that you see here, the key focus is that for assembly, a flat submount can be used. The device is assembled on top, and then the space that's needed for the device in the package is actually provided by the lid. And now the silica window, what we name it here, is made completely out of fused silica. So in the deep UV LED wavelength range, you need a fused silica for best transmission. And we can have a dam structure hermetically connected to a lid structure, both of them being transparent to have a very broad emission of the LED. And so with the advantage that the light is not lost in the sidewall, but actually extracted from the package. And on the right side, you see what we call the reflector windows. And here the dam is actually a silicon shaped with an angle and a mirror coating. And this is why it's called reflector window, because it acts as a mirror and side emitted light of the LEDs transferred to the top. Now, in our products, of course, we can integrate anti-reflective coatings and reflector coatings here. And at the bottom, we can integrate metal for hermetic solder attachment. Next slide illustrates a little bit better how it works for the side emitted light. So you can see in this simple ray tracing that the light that's emitted to the side is added towards the top. So the light extraction of the full packaged LED is much better than this conventional packaging. On top is that this light is actually used and not turned into heat, so the thermal performance of our packages is improved. And as said, we can make very small outlines. We can design this as array packages for hermetic or non-hermetic packages as it is required by the customer. A very similar approach taking for other emitters, for laser diodes. Also here, still a lot of packaging with TO cans, large and bulky. Arrays are not possible, and there are SMD packages around which use mirrors, normally glass mirrors. So one product that we can offer are these silicon micro mirrors made of silicon, that can be used as a replacement for the glass mirrors. We can have excellent surface quality, so the mirror is very smooth. We can add high reflectivity coatings, not only metals, but also dielectric coatings. And again, the mirror, as well as a lid that's placed over it, can have a metallization fit for soldering. And as with most of our product, this is again designed so that the actual part assembly is done on a flat submount, and then a lid provides the space in the package for the parts. And now this is, of course, for a side-emitting laser diode for reflecting the light towards the top. And we can integrate this mirror also into the sidewall of a cap, allowing for the most compact package, and allowing a very, very small SMD package with high performance anti-reflective and coatings, as well as high reflectivity on the mirror plane. For sensors, this is, let me skip that because I'm a little bit delayed in time. So for sensors, we do similar things. This is an example of a very simple sensor package that we have come across more often. It's a thin glass glued onto the sensor with several drawbacks. Of course, you have glue in the optical area. The glue can have bubbles, inclusions. It can discolor over time. And since this is a back-end process, you can have particle contamination. And we actually have a front-end process to deposit thin film glass film. It's a low temperature glass deposition process below 80 degrees Celsius. So we can use a simple lift-off structuring to keep one path open. And you could, for instance, make a very simple plastic mold package. But since the glass film is directly sealing the opto sensor, you will have a very good reliability and a very good optical performance. Again, also with sensors, we can use our lid concept, and you have an assembly on a flat submount and provide a lid. In this case, it's a glass silicon compound to cover it for packages like sensors, but also LED. And the hermeticity that's achieved just depends, of course, on how it's attached and what kind of submount you choose. So you can see here the FR4 is clearly not hermetic, but it's hermetic enough to be qualified for an automotive product. And image sensors is more of a niche market. As you may know, most is done in either wafer-level chip size packaging, where a glass lid is attached with an epoxy dam to the silicon sensor on wafer level, and then after adding the contact, it's cut into pieces. Or if it's a chip on board package, a piece of glass is glued into the package with a thick epoxy dam. This works sufficiently well for most applications, but the larger the image sensor gets and the larger the package needs to get, the CTE mismatch of the materials turns out to be a bigger problem, because the epoxy will just expand much stronger on temperature change, and so reliability is an issue. For this, we have wafer level or die level capping technologies. On the wafer level technology, we add these glass lids, which actually have a glass dam. So there is no glue or whatsoever, a small cavity on the optical sensing part. But underneath the dam, there's a very thin glue line, allowing for a higher reliability. And this can be done either for very small components, and many components are then attached at the same time, the glass lid being smaller than the chip, but the bond pad's still free to make this chip on board packages. And it can be done for large components like this image sensor you can see here. And this is the wafer level capping, but we also can make glass caps with higher standoff for back-end assembly. There you clearly need the higher standoff to keep away particles. But the wafer level capping has a very good performance because of the cleanliness in the whole processing. Now, a short overview of other components or parts that we make. I already talked about wafer level capping, but we can do all sorts of microstructured glass substrates, silicon cavity wafers, or other glass cavity wafers, compound wafers, where different materials are bonded on wafer level together. And the reflector parts, like shown for UV LEDs, but also visible, or IR is of course doable. And a part of our processes we source out is foundry services as well. We have wafer bonding for anodic and fusion bonding, as well as glue bonding, our proprietary low temperature glass deposition, as well as all sorts of wet etching processes for glass, silicon metals, and other processes, metalizations, laser structuring, down to wafer dicing. With that, I'd like to thank you for your attention. Sorry again for starting late. I hope there's still enough time to get through this presentation. If you have questions, please contact me here at the conference, or drop us an email at sales@lithoglass.de or visit our website. Thank you very much.